So, anybody have any questions from anything? You guys remember the, what do you call it? Oh, let's see, wait a minute. There are people. Oh, okay. Are you here right now? All right, let me do this. I'm going to have to email the link to the class because there might be people that rely on getting it from Canvas. And of course, they can't get into Canvas right now. So give me a minute, everybody. Let me stop recording because this is exciting. That was fantastic. So at the beginning of the week, I mean, Canvas is another website. It can go down anytime. If you have your Canvas notifications turned on, you should probably get an email from Canvas with the announcement. Is that how it works for some of you guys? Do you guys get emails like over the weekend from Canvas? Yes? Okay. Yeah, so that's the way to do it. Because I'm not going to send it out. Well, anyway, we'll see. It's the first time Canvas has gone down since I started using it that I know of. So it's not a bad track record. All right, guys, anybody have questions from chapter 3 homework, considering that's the quiz that's happening after class?
I have a question about the quiz, chapter 3, that we have to submit in modules. Is that the one that we did in class that says double quiz on the, is it a sheet?
Wait a minute. Start over?
In modules, under unit 3, it has chapter 3.
Oh yeah, you had asked me about this. All right, let me show everybody. All right, now listen. There's in the homework, there's section 3.1, 3.2, 3.3, 3.4, and then there's a chapter 3 review, right? Mm-hmm. Assignment. It's like number 119 and 120, whatever. So however you access the book, if you are doing the homework and you get to like, don't you have to do 112, right? All right, and then you go down to like, all right, now I got to do 119. Let me see, where's 119? Oh, wait a minute, what? And then you just go to the next page. I mean, that's all. So if you printed out the book, if you have a printout or a PDF, then you just go to the next page. Yeah. So it should go to 117, 118, and there's 119 and 120. You got to do. Is everybody with me? I would show it to you on Canvas, but I currently can't. Hold on. Let me see. Canvas? No, you're still dead.
That's weird. I was able to get into it.
Oh, wait a minute. There it is. All right. It took it a second, but there it is. So it looks like it's back up. Well, yeah, it's sort of back up. Somehow I got a bunch of emails on Canvas. How do people do that? Let me see if I can maneuver through Canvas. Come on, Canvas. I think it's the Russians. What do you guys think? Trying to hack into Canvas. All right. Putin's trying to disrupt our educational system. Right here, this assignment. All right, what's happening? This chapter 3 review, this one, right?
Oh, okay.
Yeah, so it's just on the next page. It's just on the next page. That's all. Yeah. Let me see. All right, so any questions from homework? Any questions from anything? There's the practice quiz also, right? You guys remember the practice quiz is up here that you could look at if you want to. Right, you leave your friends behind.
Can we work through 128? I'm having trouble not like figuring out how to do it without using the contingency table.
Oh yeah.
We're 128, so let's see. Yeah, okay. Of those cases, 6.4% through heterosexual contact, 7.4% are female, out of the females with the disease. So this is a great place to collect what you know. 3,059 cases of AIDS have been reported. Of those cases, so here's the probability of heterosexual contact, 6.4%. Here's the probability of a female who got AIDS, 7.4%. So look here, probability the person is female. Well, that's pretty straightforward.
Like, wouldn't it just
right?
be 7.4?
Yes.
Okay.
Probability person obtained the disease who had sexual contact. They told you that. Where things get interesting is probably person is female given the person got the disease, and even that they just tell you. Yeah, so 128 they just tell you. It doesn't get interesting at all.
All right, I guess I overcomplicated that one.
But those, it's kind of the same idea as that number 50 something and the number 80, where they give you some stuff and people try to use formulas, but they just told you the probability. So it's, let's look at that kind of problem real quick. Like number 80, I'm pretty sure we looked at this the other day, but what I would do on this problem is before I look at any questions, I would use the symbols they give me and identify each of these probabilities with their symbols. Then I won't make a mistake when I get down to here. So there are 4 probabilities, and the first 4 questions, no work. You just get the numbers from the write-up. Are you guys okay out there? And you have to understand, out of those California given California voters who support same-sex marriage. So out of is kind of another word for given. Among is another word for given. If I say among 18 to 39-year-olds, then I'm given that they're 18 to 39 years old. I don't know if that helps anybody. Obviously, I hope it does. Anything else from anything, guys? Homework or the practice quiz? Let me see. I was going to show you where that was.
It's not gonna be a good quiz.
If you go to Unit 3, there's the probability worksheet with the practice quiz on the back, and then here's the probability. I should say practice quiz answer. Sorry. Here's the practice quiz answers. All right, guys. So let me ask one more time, because if nobody has questions from the chapter 3, we're just going to keep going. Does anyone have questions from chapter 3 in any form?
Can you go one more time to explain most the mutually exclusive and not, because they are a little bit confusing sometimes to me. So I want to make sure, like when I answer, there's like answer sometimes A, B, C, D. Okay, I know the answer, but sometimes I don't know exactly how to put, like, to show the work.
So if they ask you, are these things mutually exclusive? What do you have to show? What does it mean for 2 things to be? All right, so if I tell you that A and B are mutually exclusive, what can you write down? So if I just tell you
They are equal to 0, not equal to 0, or I'm not sure. Like I get confused with these things.
mutually exclusive, they mutually exclude each other. So then what's the probability that they happen at the same time?
They are both 0.
No, don't say both. The probability that these things occur at the same time is 0.
Together. Oh, okay. At the
Probability
same,
of A could be whatever, probability of B could be whatever, but if they're
Mm.
mutually exclusive, they can't occur at the same time. So if the question tells you they're mutually exclusive, write this down immediately. If the problem says, are they, check this to see if it's equal to 0.
Mhm.
Is
Okay.
everybody with me so far? So don't skip over when it says these are mutually exclusive. That's huge information. You gotta write that down immediately. What if I said C and D are independent? What can I write down? I don't know if you're better.
Probability of A given B equals probability of A. C and D, sorry.
You can do it the other way around too. It doesn't really matter. Okay, so if they tell you this is true, you know these two things are true. If they ask you if this is true, check either one of these to make sure it's true. Is that, you guys with me out there? So the only way to answer a question, if I say, are these independent? The only way to answer that question is to do this work or this one, either one. Show me this is true. Or if it's not true, then you say it's dependent, that they are dependent events. Oh, all right. Which problem are you looking at? Because it depends on what information they give you. Which problem? All of them. All right. Can you pick one? For example, do you guys remember if I give you a problem like this, right? Where you can just count everything. Yes, no, A, B, C, whatever the hell. Let's just do A, B. There you go. A, B, yes, no. If I said, given, what's the probability that they said yes, given B? I don't need a formula for that. Man, both of my pens are dead. I don't need a formula for this. Right, so let's look at this situation. Given B, so how many am I talking about? Given B. I don't know if you guys can see that. Yeah, I'm talking about 14 things, right? Given this. So screw everybody else. How many match what I'm looking for?
3.
Yes, done. Next. No formula needed. I just needed the idea. The formula would work. It would just be much harder. Probabilities are all about counting. If I have everything I need to count, I don't need the formulas. Okay. So here's a different kind of problem. What if I told you probability of F and G is 0.3, and the probability of F is 0.7, and then I say, what's the probability of G given F? Well, what's the formula for this?
Probability of F and G divided by probability of F.
Yeah, the bottom is going to be that. Do I have everything I need? Yes. Bam. So if you're stuck on a probability question where I just gave you numbers like this, look at my question, write the formula for it, and then look back and say, do I have everything I need? Yes. And if you don't have everything you need, did I give you information to figure out what you need? I must have, or else it would be an exceptionally evil question. Okay. Is that better? I'll take that as a yes. Okay. So with the and do I add? Uh-oh. All right. If there's one thing I want you to come out here, and there's more than one thing, but if there's one thing, it's this idea. And is basically multiply, or is basically add. Right? Why do I say basically? Because or is one plus the other minus any that are both, right? There's a little adjustment. And is one times the given of the other one. It's a little bit of an adjustment, right? So like if I take a card and I throw it away, the next probability is a little different than it would have been. Does that make any sense? That's why I say basically add for or, basically multiply for and, because there's a little adjustment. I really want this to be understood. All right. Anything else from anything else? It's okay.
From question 100, there's just one part that I'm confused on. They gave us a percentage, and I'm not sure what probability that would be.
Question 100. Oh, all right. Let's take a look. Get out of here. Oh. So college finds that 10% take a distance learning, and that's D. So what's that right there? Just stop. Don't even look at anything else. I know the letter and I know the number. So what is the symbol for this?
Probability of D.
Yep, that's probability D. So I know the probability D is 0.1. And 40% are part-time.
Probability of E.
Such a weird choice, but oh well. Everybody with me? Even before I get to the questions, I just sort of, and now what would this be? What would 20% be? Of the part-time students, 20% have taken a distance learning class. So of the part-time students, what is that another word for? Of the part-time students. What kind of student is it in this sentence? What kind of student do I know I'm talking about?
No part-time.
Does everybody get that? Of the part-time students. So aren't I talking just about the part-time students? So isn't it given that it's a part-time? So given they're part-time, 20% have taken a distance learning class. The probability they've taken a distance learning class, given that they're part-time. And by the way, I know this looks like it says die. Don't worry. Okay. So we did all that before we looked at the questions. Now the questions should be a little easier. What's the formula? What's the formula for A and B? There's two actually. There's two that work.
Probability of A times probability of B given A.
Good. Oh crap! I hate my pen does that weird. Yeah. It thinks it's a graffiti artist. I think. All right. Probability of A probably B, or probability of B times the probability of A given B. So it just has to be one times the adjusted other one. It doesn't matter. Because again, probably A and B is the same as the probability of B and A. It doesn't matter which letter comes first. Let me stop for a minute. So considering what I know, I should probably write this in the way that I could use this. Do you see what I'm talking about? Because I know this. So if this is D given E, what goes here?
Point one.
Well, tell me the symbol.
Oh, probability of D?
No,
No?
E.
it's so weird. So, real quick, when I have my speaker set to Bluetooth, some of you guys are so quiet, and then some of you guys are like not. So, so that's on my end. That's my technology. So, all right, let me see. I love you guys so much. So let me do it like this. Let me do it like this. Is everybody understanding what I've written over here? All right.
Yes.
So what two ways could I do this problem then? It could be probability of D times probability of E given D. So probability of D, so D happened, times the probability of E given that D happened, because it did. Or the probability of E times the probability of D given that E happened, because it freaking did, right? Now, which one of those do I have all the information for? The first one or the second one? Do I know this?
The second one?
The second one, I know this and I know this. So that's the one I'm going to use. I throw it all in there, multiply, done. Next problem, please. Do you guys get that?
So how
The
would you
and-
find,
Sorry, go ahead.
how would you find part B? Since it's
Okay. Hold on. So what I was about to say is the and is a little weird because it's got two ways, but why does that make sense? Because the probability of A and B should be the same as the probability of B and A. It doesn't matter which letter is first. Does that make sense? That's why there's like two ways. Either A is first or B is first. Who cares which is first? They're both the same thing. If I said Sam and Bill, come on, Sam and Bill. And then I look back and okay, Bill and Sam, and like, we're not Bill and Sam, we're Sam and Bill. I'm like, who gives a shit? Right? Maybe? Or maybe it's Sam and Frodo. I don't know. Anyway, let me erase all this. Oh, I don't want to erase all of it. So let me try to do a strategic erasing guy. All right, so what's the formula for E given D? There's only one formula for that. Oops, I just need to give myself some more room. Anybody? All right, somebody's got it in chat for me. So definitely on the bottom is the given. I love it. And on the top, it's E and D. And do I have all of that? I just calculated this, bam. And I've known this for a little while, bam. Now, at this point, if you've done this homework in chapter 3, you understand that most of these problems kind of build, right? Whatever you got in part A comes up in part B or part C, and whatever you got there comes up in part D. It's like, what the shit? And then for part C, you just write the formula for this guy, and you know everything you need for the formula. So you just throw everything in and calculate it. Is that okay? It's all about writing the formula for what I ask you and then throwing in what you know. Do you guys get that? No?
Wait, so
Hey,
is B, there's an arrow pointing to the same thing as A.
oh, no, sorry, because so you gotta follow with me and not look at the end result. So what I did was I wrote what this is. Here's the little arrow is coming over here and is saying that this equals this, right? Equals this piece. And then I said, we know the top from the first part.
Oh, okay. So when we
And
do E and D, then, or E given D, the top we'll work it out and it'll look like that.
Yeah, because part A is the number you need for the top of part B.
Okay, I got it.
Cool. So there is a reason they ask some of these things in a certain order. Is that how you guys feeling? Like 2% better? No? 0.6% better? No? You're not listening to me anymore? No? Canvas is taking a break, so why shouldn't I? Professor, I'm back in bed. Leave me alone. 1.8% better. I like that. And then somebody else is like, I'm not going to do the math thing for you, math boy. I'm just a little better. Okay. All right. Anything else from chapter 3 homework or the practice quiz or anything before we get back into chapter 4?
It's gonna be my lowest quiz score.
Come on now. Don't go into it like that. You don't know.
It's like that Simpsons episode. It's the lowest quiz score so far.
Right.
Simpsons did it. Let me see. All right, let's look at the practice quiz real quick. So what do you know you're going to see? You know you're going to see a table, and then everything in red is what you would write, correct? You know you're going to see a table like this. You know you're going to write the totals on the outside. You know you're going to get this kind of question. Okay. I mean, you basically know you're going to get all these questions, right? I mean, you know you're going to get this kind of question where
I have a
it's
question for
yes,
each.
yes.
For each, do we just put like our work, or do we actually have to write it in words as well?
I just, this is not necessary. This is just a little bit extra from me. This is all you need to show me right here. Right? Because if they're going to be independent, then these two things have to equal each other, right? I really want, is everybody, please let that make all the sense. This I think is the, how do I say this without making you feel bad? This is the thing in all the courses I have ever taught that I cannot be explaining it correctly because it makes all the sense in the world. You're like, good for you, math boy. But the only way that being a man and owning a Toyota from this data could be independent is if I know they own a Toyota, but the probability they're a man doesn't change. But I know it changed. There's a probability they're a dude, and there's a probability they're a dude if I know they own a Toyota. It did change. Therefore, the probability they're a dude depends on if I know they own a Toyota. That's why the given is the thing I have to check. If I know this thing happened, does it change the probability of the first thing? In this case, yes. And this sentence I wrote is just making it really clear. If I know they own a Toyota, the probability it's a dude went down.
I think what I've been confused because right here it says being a male and towing, so I would have put
Okay. Now listen.
and T.
Listen, guys, listen. Help me out. The word and is an English word, right? So are the events being male? What word would I put here instead of and? So I understand. Do you understand? So are these events independent? I could say it like this. Are these events independent? Male, comma, owning a Toyota. But man, that just sounds weird. I'm going to have to use the word and sometimes, just as the English word and. Are being male and owning a Toyota independent, right? This and doesn't mean shit. It just means I have two ideas and I want to know if those two ideas are independent. And what word do we use in English to separate two things, and this and that? Is that cool? So the and wasn't the probability and, it was just the word and. And I understand, trust me, I do. There we go. Look at that. Maris offering. And yeah, don't forget, guys, if you signed up for Zoom if you have a free thing for Zoom, you could have a meeting of 3 people for free over Zoom. And of course, you guys got Skype and all the other shit, right? I mean, I don't even know what else you guys got. So yeah, you can do study groups. So that's not a bad idea. I don't know if anybody's going to take you up on that, but it's nice to see that trying to happen. Okay. You know you're going to see a problem like this with replacement, without replacement, right? There we go. Somebody's in. There we go. Look at that. Stuff's happening. I'm going to start to cry. I'm going to cry.
Me too.
I'm going to cry. So this is what I hate about not being in a room together. This kind of thing is harder for you guys to do.
Mhm.
But anytime you want to, you can chat to each other about this kind of stuff. If it's getting a little excessive while I'm lecturing, I'll tell you to shut the hell up. But I mean, you know, just like we would in a classroom, right? You guys can talk to each other. And if it's too much, I'll say, shut the hell up. Or maybe I won't say that. I wouldn't say it exactly like that. There we go. Look at that. Look at that. This is beautiful. Okay. Oh. So, and on Canvas, there's an option. I could have opened it up so that you could message each other, but that kind of opens things up to people being harassed by other people easier. So I didn't, it's a weird thing to figure out on my side. So anyway, you guys can put your contact stuff down in chat if you want to, or if somebody sets up something for us for a study group, you could send the information to me and I can send it out to everybody. Whatever works. Okay. Anything else, guys? Oh, like I said, you can either do it over Zoom, you could do it over Skype, you could do it, what else? What else is out there? You guys know better than me. Discord, very good point. I don't know if everybody knows about Discord though.
I don't know what that is.
I could, if you tell me what time, I could even set up a meeting for you and allow you to meet before I join, and then I just never join. Do you guys understand what I'm saying? So since it's through my account, everybody could actually go free. So if you want to do that, just somebody needs to email me and I can set something up, and then I can send it out to everybody.
This evening, maybe.
What's that?
This evening.
Yeah, see, that's on you guys. Good luck. So I'll set it up as long as you guys figure out when it's going to happen. I got enough other meetings to try to schedule with people. It's insane. So I don't know what group me is. All right. So I'll let you guys think about that.
Yeah, that's what I was thinking. 6 o'clock.
Well, after we just went over the whole and thing, do you think we could do 128C? Find a person is female given person got the disease from heterosexual contact.
All right, wait a minute. Oh, 128.
128C.
Six p.m. Okay, so I can somebody in that group email me and remind me? I can set up a Zoom meet. I'll send it out to everybody, and I'll set it so that I don't have to be there for you to log in. That should work, because I'll be in class at 6. I got a class that goes till 7. Let me see. Hold on. You said 128.
Yeah, 128C.
So what's the formula for that? So one thing I don't like about this problem that you could improve on is why are they using so many letters? We should call this probably a female, and we should call this probability heterosexual contact, right? So this would be the probability female given heterosexual contact. So what's that formula?
Probability female
Actually,
times.
wait. Sorry. Now I'm remembering this problem and I'm looking back at it. How many probabilities do they give you in the write-up? Three. Right? Here's the female. Here's the heterosexual contact. And what's this one? Out of females. So given female, 53 got from heterosexual contact. So this is heterosexual contact given female. Right?
Oh, it just gives it to you.
Careful. What's this probability? Isn't this going to be probability female
Given.
Now everybody stay with me. Didn't we write this down earlier? I know we did when we looked at this, right? Did we identify each of these things? Now watch. Oh, you're going to love this. What's the formula for, well, actually, let's do this. What's the formula for what they asked me? So this is what they're asking me in part C. So what is the formula for what they're asking me?
Female times hetero.
No. Definitely not.
And H, F and H.
And on the bottom goes the given. I like it. Now, do I have this? Check. I have that. Check. Do I have this? No. But I do have this. So what did I do? What have I just done? This is what they asked me. I wrote the equation for what they asked me, and I step back and I say, okay, I got that, check. Do I have that? No. Then I go, shit. And then I go, what have I not used yet? They did give me this, where the given is wrong, right? It's like the wrong way around. Stay with me. I could just feel you guys like going, nah. Fuck. All right. What's the formula for what they told me? What's the formula for this one? You could do it. Just what's the formula? Sorry?
H and F over F.
Do I know this?
Yes.
Check. Do I know this?
Yes.
Check. Can I solve for this? Yes. Can I then plug that thing in here? Check. I really want you guys to understand there isn't a set thing to what I just did. I write the formula for what they ask me, and then I say, do I have everything I need? I had some piece of what I needed, and the other thing, I didn't have it. Damn. So I go, shit. So I got to go, okay, what else do I know? I know this weird thing. All right, let me write its formula down. Holy shit. Up top is what I need. I got this. Okay, I could figure out what I need. For the other formula. And you're all like, your tone makes it sound like it's easy. I'm sorry. It isn't easy. I'm sorry if I'm coming off that way. But it's not as impossible as it sounds. It's making sure. Have you guys ever seen Princess Bride?
Oh yeah.
And anyway, this maybe is the wrong time to do that. I'm sorry. It's making sure you know all the tools you have, right? I have this, I have this, I have this. And then using them when you need to. Sort of like when he didn't say at first he had a Holocaust cloak, and he actually had a Holocaust cloak, and he didn't say that. Anyway, all right, enough about that movie. I don't know.
Oh.
All right.
I have questions. So PHNF is equal to PFANH is the same value.
It has to be, right? So that was
Mm,
that silly thing I was talking about earlier. If
uh-huh.
I say Phil and Sam, come with me, and
Okay,
then later
okay.
I say Sam and Bill, and they're like, we're not Sam and Bill, we're Bill and Sam. No, you're Sam and Bill, you're Bill and Sam, who cares?
Okay.
Right?
Totally got it. Okay.
Okay, good. And so those are interchangeable, yes. And it won't change the meaning or anything because that's how the word and works. Yeah. Let's do this problem, huh? Is that what you guys want? All right, let me start fresh. Let me clear these. Let's start fresh. All right, so let's really keep track of what we know. All right, so I know that the probability of female is 7.4. So I'll make it 0.074. I know the probability of heterosexual, and this is all, probability of female that has 8s, the probability of heterosexual contact and got 8s. And then, so that's really part A and B. Now, part C, they ask me this, female, given they got it heterosexual contact, and I write down the formula for that. And then I realize, okay, I got that, yes, and I don't have that, shit. But I do have the probability of given female heterosexual contact. You can do better. Okay, let me stop for a minute. So that I haven't done anything crazy. This is just summarizing what I know. And this is just writing the formula for what I'm asked. You should always do those two things in this kind of problem. The thing that's a little different on this problem is I'm given some information that has its own formula. And from this one, I can figure this piece out, which I need here. So let's throw everything in. What is this? What's the value of H given F? Probability of H given F?
Uh, 0.064 given.
Stop. I need you guys to understand H doesn't have a value. The probability of H has a value, but that's not what I want right now. I want the probability of H given F. What's that value? One number. Yes.
533.
533. That's what it is. And this equals whatever the hell this is. I didn't give myself enough room here, but oh well. Divided by what's the probability of F?
0.074.
Yep, 0.74. I like it. Now, how do I solve for this? We write that up here. I got 0.533 equals probability of H and F divided by 0.074. Please tell me you know how to solve for this. How do I get this by itself? What do I do to both sides? What do I want to get rid of if I want this by itself? Why is he not by himself? Who's with him? Come on, guys. Who's with this?
Multiply?
0.
Yeah.
Or 0.074.
If I multiply both sides by 0.074. So who's with this guy? This stupid guy. What's this dumb guy doing? Dividing my poor dude. So let me multiply by that jerk so he goes away. And of course, I got to do it to both sides to keep it legal, right? Good old algebra. So now I know what the probability of H and F is. What would that be? What is this? I think it's like 0.4 something maybe. Is it right around 0.4? 0.039? Is that what it is?
0.039.
Okay. And now going back, this is the actual part C question. Do I know this? Check.
Yes.
Do I know this? Check. So now I can throw that stuff in. 0.039 divided by 0.064, and then whatever the hell that is. Three halves.
.616.
Sounds about right. Woo! All right. Was that easy? No. I want you to understand that wasn't easy. But it's a situation of they want something from me. They always want something from me. So here's what they want from me. Okay, let me write the equation. Now I know what I need. I need this. I got this. I need this. I don't have this. Damn. So that was what all this other work was getting the top that I needed to answer their crazy question. Okay. That's probably one of the hardest questions in there. Well, it's the last damn question in the whole thing, so that kind of makes sense. All right, all right, all right. So when I give you values for situations, like percentages for situations, and then I start asking you questions, it's best to summarize what you know, so that when you get to a question, maybe the question, you just know it. Oh, I just know that. Bam, no work. And I just know this. Bam, no work. And then you get to the part that needs work. You write the equation for what you need. Okay, all right. Anything else, guys? All right. I think I've made everybody go quiet. All right. So let's get back into where we left off. I think, did we finish that handout, right? Let me see.
Yeah, we did.
Yeah, the one from chapter 4. All right. Okay. So a real quick recap. Plus, in case not everybody heard this, the formulas are on the quiz, right? At the very end of the quiz, there's a little box that's got all the formulas in there. Okay, all right. So, very quick recap of what we've done so far in chapter 4, and then we're gonna maybe finish it. Let's see. So 4.1 and 4.2 deal with if I give you data like this, right? So then you have to do x times p of x. So if a real quick example, you can do it, Jeff, right? What do these have to sum up to be at least close to?
1.
1.
Thankfully, these two add up to be 1. How do I calculate the mean? The mean is going to be the sum of those guys, the value times the weight. And we actually created that formula last time. So if I just multiply across and then add down, I'll get this. So that looks like it's 2.5. Now, real quick, why does it make sense that the mean isn't 2, that it's actually 2.5? Why does that, anybody see why that makes sense?
The 3 is heavier.
Yeah, there's more 3s. 60% of the data is 3s. So that's going to pull the mean up. So it makes sense to be about 2.5. I like it. I also like thinking it's heavier, so it's gravitational pull. I like that. Okay. And then we did this funky stuff where I brought algebra in that you never thought algebra should be. And we figured out a better way to get the standard deviation was using this. And funky ass Jeff, he likes to do this times this to get that, because it makes sense to me. X times x is x squared. So you do 1 times 0.1, 2 times 0.6, and 3 times 1.8. So the sum of x squared p of x would be 6.7. Then again, there's a handout up on Canvas. It's got a worked out example of this. So the mean is 2.5. The variance is going to be this stuff minus the square of the mean. So when we take this quiz in the future, these formulas will be on the quiz. So I know what this is, 6.7. I know what the mean is, 2.5. So my variance will be the difference in those two, and I think that's 0.45. But no one's going to help me, so it's too bad for me. Nobody likes me.
It is.
Yeah, 0.45.
I think. And then to get to standard deviation, I don't have enough board space. This is crazy. Standard deviation is going to be the square root of that, right? Because I haven't square rooted it yet. And I believe that's going to be 0.6. I don't know. 6.
Wait, what did you square for the fourth column?
Here?
Yeah.
All right. So what I do,
0.6.
I need x squared p of x. What I do is I say x times x p of x. Isn't that
yeah.
x?
Okay.
Now you could do, now watch, I really want you guys to understand math doesn't give a shit which way we get there. Couldn't I square this and multiply by this? Wouldn't that be x squared p of x? What's 1 squared times 0.1? 0.1. What's 2 squared? 4 times 0.3? 1.2. What's 3 squared? 9 times 0.6? 5.4. Math don't give a shit. Sorry if there's little people.
You push your board out a little bit.
It's not thunderstorms anymore. It's cloudy now.
Nikisha, what's up?
Could you push the board back a little bit?
Oh, yeah. So then standard deviation, I think this is like 0.67 maybe? I don't know.
0.6708.
670, 11. Look at that. So 671. Which makes sense. If the mean is 2.5, 60% of the data is half away from it. So, I mean, on average, the data is 0.6. That makes some sense. I have no idea if you followed what I just said, but that standard deviation does make sense. All right, so that's very quick because you've already done a couple examples of this stuff. So that's what we did in 4.1.4.2. So now we're going to get into 4.3. Okay. I'm going to erase all this. Here it goes. Bye. Bye stuff. Good to know you. All right. Now, ooh, it's really raining out there. Jeez. There. Now watch this. We've done a problem. We did a, now stay with me. If the probability somebody's left-handed is around 11%. Okay. And the probability somebody is not left-handed, the book uses a dumb little thing. I use this for not left-handed. If somebody, it's probably somebody's left-handed is 0.11, what's probably they're not left-handed?
89.
89.
0.89.
Yeah. Why don't I just say right-handed here?
Because they could be ambidextrous.
Could be ambidextrous.
They could not have a left hand.
They could not have a hand, right? They could lose both their hands, right? Okay. So this kind of covers all things. It's a default dichotomy. This or not this. All right, stay with me, stay with me. We've done this kind of problem before, what I'm about to do. We did it back in chapter 3, so long ago. We did, if I have, pick 4 people, what's the probability that the first one is left-handed, while the last 3 aren't? Do you guys remember doing this kind of problem? No, we did the one with I can't remember now. So how would I do this? Remember, it was the hangman game. I have 4 people, right? 4 people. I want the first one to be left-handed, so that's going to be 0.11 chance. And the next one to not be left-handed, so that's going to be an 89, and the next one not left-handed, and the next one not left-handed. All right, is everybody with me? And means multiply, that's why I multiply. So then I could just multiply this all out, whatever I get there. Let me see, wait, 8, 7, 0, 7, 0, 7, 0, 7, I don't know. How close did I get? Probably 069 or I don't know, 07. Nobody's gonna help me?
0775.
Okay. Thank you. All right, nothing amazing, nothing to see there. Very straightforward. Can somebody tell me the difference between what we just did? What if I say this? Why is this a different problem? Pick 4 people. What's the probability that at least one, oh, Jeff, don't even do that. Not yet. What's probably that exactly one is left-handed? What's the difference between these 2 problems?
You're not counting the last 3? No?
It's kind of like the other way around.
Would it just be 1 out of 4 people?
Definitely not. Definitely not. So what is this? This is the probability that the first one is left-handed, correct? Corbin's onto something. The probability that exactly one is left-handed, isn't this just one way that could happen? What's another way that could happen? The first one could be left-handed, or, come on, play with me. Either the first one's left-handed, or if you got 4 people lined up against the wall, and one of them stole your cheese. I have no idea where that came from. Who could it be? You know one of them did it. It could be the first guy, or
The other 3.
the second guy, or the third guy, or the fourth guy. I love it. I love it. So this is too specific for this. This is more general. Exactly one left-handed person would be this, plus this, where the second one plus. All right, let me focus on this. Okay, so this is the new stuff we're getting into right now. All right, here we go. I know. I'll put it up here. Let me make this smaller. So one thing I'm going to do to make this a little easier to talk about, is I'm going to call this probability little p. That's a little p. And this probability q. Mind your p's and q's. So, all right, there you go. Just so I don't, just because. So now watch what I can do then. The probability that I have exactly one left-handed person, if I pick 4 people, how could it be? It could be the first one is left-handed, and the second one isn't, third one isn't, fourth one isn't, or means add, right? Or how else could it happen? How else could it have exactly one left-handed person? So either the
Would it
first
be
one
Q,
is
P, oh, sorry.
Q, P, Q, Q, right? Either the first one is, or the second one is, or the third one is, or the fourth one is. Have I done all of the options? Is there any other way? No. Right, and I want you guys, let me remind you guys something. Are you gonna have to do this ever? No. We're gonna develop a formula, because how long was this list I just made? Is this a long list? No. I mean, come on, 4 things, not a long list. If I had 80 people that I picked, and I wanna know the probability that 10, I really want you to understand, we don't wanna do this math. I wanna develop a formula where I can just do it real quick, because watch this. What if I had 80 people? I really want you guys to do it with me. 80 people, and I want 10 of them to be left-handed. It could be the first 10, or it could be the last 10, or it could be the middle 10, or it could be the first 2 and the middle 3 and the last, holy. I'm going to be curious later. I'm sorry. I have no idea I got that close. On the calculator later, we are going to see if the calculator, I think it can handle this. We're actually going to figure out how long this list would be, but can you understand? It could be the first one, but not the second one, and then the next 3, and not the second 5, and the thing. Holy shit! I have no idea if there's little kids. I gotta use German. I could also use slang language to cuss, maybe if I need to. All right. Stay with me now. So I'm gonna put this little note over here. 80 people, 10 lefties. So we'll figure out how long that list would be. All right. We'll do that later. Now, if math looked at all this, it would laugh at us. What is this? What is P times Q times Q times Q? What's a better way to write that? P times Q times Q times Q. What does algebra do for us?
P times Q to the third.
And isn't each of those the same thing? So aren't there 4? There are 4, right? Because I'm adding 4PQ to the third. Now look at this. Look at this. You got to let this be nice. Look at this beautiful thing. What does this mean? The fact that there's 1P, because I want 1 left-handed person. So that means I want 3 not left-handed people. I want 1 of those and 3 of those, and there's 4 ways to do it. Bam. Bam. The part of this is going to be difficult for us would be this part. It was easy here, but it won't be easy there. So thank God the calculator can do that part for us.
Oh, whichever it's asking for, like, say, for example, it's asking for 2 left-handed, would you put P and exponent of 2?
So then it would have been.
What?
It would have been P squared.
Okay.
Okay. It's a lot happening. So let's figure out what this is. What was the value of P?
1?
What?
Oh, 0.11.
Yeah, P and Q are probabilities. So they're probably somewhere between 0 and 1. So this will be 0.11. And what's the value of Q?
0.89.
0.89. And I got 3 of those bad boys. Can you throw that in your calculator real quick? Well, shit, Jeff. There you go, buddy.
23,
Who's got that? See if you remember how many places to take this to.
Zero 0.3916.
No,
0.3102.
there it is. I'm not sure what happened to you. You got close. 4 times 0.11 times 0.89 to the third power, right?
The third power might have been inside the parentheses.
Oh, that doesn't matter. I only put parentheses that denote time. So it'd be 4 times 0.11 times 0.89 to the third power. Does everybody get that answer? You get 310,186, blah, blah, whatever. So you round it to 3102. Okay. Let me know if you don't get it. Okay, all right. So let's look at that. All right, now watch. I should leave you guys at there. All right. So what do? If I want, so now I pick 80 people. What's the probability that I get exactly 10 left-handed people? I should have thought, yeah, I think this will, okay, this should work. The calculator should not freak out about this. So let me show you. Okay, now watch. How much can we do already by ourselves? I don't know. So the number, remember, why was that 4 there? Somebody remind me, why was that 4 there?
Because there's 4 people.
No, I appreciate that, but that's not the right answer. I'm sorry.
4 possibilities.
There were 4 total possibilities, right? Okay. All right, maybe we should do, no, screw it. Because the list we made only had 4 things in it, right? Maybe we should do an intermediate step. Yeah, before we do 80, let's do pick 4. Let's probably get exactly 2 left-handed. So that would be like PPQQ or PQPQ or PQQP or. You guys doing okay out there? QPPQ or QPQP or QQPP. I feel like I left somebody out. No, I think that's everybody. I think that's everybody. That might be everybody. All right, hopefully that's everybody. PPQQPQPQ. Okay. So then what would go here then for this problem? It would be 1, 2, 3, 4, 5, 6. Right? So it'd be 6 P squared Q squared. Is that cool? P squared Q squared for each one of these. P squared Q squared. Is it? All right. So that number really doesn't have anything necessarily to do with how many people I'm picking. It has to do with how many ways there is to arrange to answer this question. And then I would throw in 0.11 and 0.89. Okay, now. This is the part you guys are not going to have to do. Because you can see how quick it is to start missing stuff. Are you with me? So you'd have to be, so we're not going to have to do that. All right. So let's do 80 and 10 now because I'm curious. So pick 80 people. What's the probability that I get exactly 10 left-handed people? So there's going to be a number like 4, like 6, but it's going to be much bigger because, again, we just barely started making the list. 10 P's and then 70 Q's, or maybe 5 P's, 7 Q's, 5 P's, and then the rest are Q. Holy shit. So there's going to be a number here that represents how long the list would be. But can somebody tell me what will the power be on the P? You could do it. How many of these do I want?
10.
10. I want 10 of these. So how many of these do I want?
70.
70. Exactly. What's always got to be true about those powers?
They have to add up to 80.
I love it. So I know everything here except for this number. All right, so let me show you on the calculator, because there ain't no way in hell we're going to make that list. And you're about to see why there's no way in freaking hell we're going to make that list. Let me show you the calculator. All right, calculator, where are you? Oh, mouse, don't go to sleep. There we go. Calculator. Okay. Move you guys over there. Calculator's coming up here. Calculator. Uh-oh, what's going on? Oh, shit. Okay, that was scary. Everything froze for a minute. All right, so let's get out of here. Watch this. Everybody get ready. So what I want to do is there's a really cool function in the calculator. Its official name is combinations. How many ways is there to combine a certain number of things from a certain bigger number of things? So that's exactly what I want. How many ways is there to combine 10? So I call it choose because the letter C. So now watch this. How many total things do we have? We have 80. From those 80, I want to choose 10. So go to math, probability. Third one down is choose. By the way, look at the exclamation mark is a math function. So maybe I'll show you what that is. But if I choose the third one, if I do the third one, this will be 80, and I want to choose 10. Now, if you have an older calculator, it's going to say 80 NCR 10. Okay, but so this means 80 things, choose 10. It's going to tell me how many ways to do that. Does anyone understand what this number is? What does this mean back here? Anybody know?
There's 4 zeros. Oh,
No.
I'm sorry, 12 zeros.
12, yeah, because this means times 10 to the 12th. So if I move the decimal over 12 times, do you understand? This is actually 1.6 trillion. Trillion.
Can you tell me to choose?
Sorry? Say again?
After on the calculator, after you pick probability, what did you put?
Here we go. Let me do it again. So 80, math, probability, number 3 for choose. 80 choose 10 things. So if I got 80 things, 80 people, and I want to choose 10 of them to be left-handed. This will tell me how many ways to do that. And it comes out to 1.6 trillion. That is how long the list would be. All right. So let me do 2 things. Let me stop sharing for just a moment. So right here, I'm going to put 80, choose 10. So over here, this would have been 4, choose 1. Remember that? Because this was when I had 1 left-handed person. So in the calculator, if I did 4, choose 1, so let's come back to the calculator. Hold on, I'll just do a couple things. If I do 4, choose 1 in the calculator real quick, it's going to come out to be 4. Bam. Remember when I did 4, choose 2 and we got 6 things? Do you guys remember that thing that just happened? When we had 4, choose 2. When I did pick and you want 2, I got 6, there's 6. So what that function does is it tells me how long that list would be. That is why we don't have to make the list, because the calculator can calculate how long the list would be. I really want you guys to be with me on this. That is the one thing we can't do by ourselves. Okay. All right. I thought I was frozen because everybody I could see, you guys were so still. I was like, oh, damn, I'm frozen. Okay. So let's put this all, here's how this is going to work the best. You put it all in here at once. So 80, math, probability 3. 8. Now here's where we got to be a little careful. If you have the newer calculator and it's like down here, you have to hit the over arrow to come back up. Are you guys with me? You don't want to stay down. You got to get the over arrow to get back up. If you have a calculator that says 80 NCR 10, you're good to keep going. So then I'm going to hit times 0.11 to the 10th. And then I have to hit the over arrow to come back down. Times 0.89 to the 70th, right? All right. So for example, if I had 80 chairs in a room and 80 people are coming and I have 10 left-handed desks, what's the probability that everybody gets the kind of desk they want? 12.2%. Do you understand what I'm saying? If 80 people are coming and there are 10 left-handed desks, the only way they can all get the desk they want is if exactly 10 left-handed people show up. Do you guys understand? This is the bare beginnings of being able to do math. For example, if you're an airline, have we talked about this yet? Has anyone ever flown on a plane? Let me stop there. Has anyone ever flown on a plane?
Yes.
Has
Yes.
anyone ever been bumped from a flight?
Yeah.
Sorry, I got so excited. I'm sorry that happened to you. Even if you've never been bumped, have you ever heard over the loudspeaker when they say, oh, you were on one this morning, dude? All right. Has anyone ever heard at the airline when they get over and does, well, we'll give you $100 and some other stuff if you will give up your seat? Has anyone ever heard that kind of thing?
Yes.
All right.
Or that one time when they kicked the doctor off and there was a huge lawsuit.
I don't know. There's so many people getting kicked off for so many things nowadays. And many of them are deservedly applauded as they are escorted out. Anyway. I lost where I was. Oh, so the reason that happens is because they sell more tickets than they have seats. Why would the jackasses do that? Or why would the business people do that? That's another name for it. Why do you think they do that?
Money.
Okay, this is true. Exactly. That's what motivates everything. But what are they thinking about? There's a probability somebody won't show up. That's like P. And there's a probability somebody will show up. That's like Q. And they have so many seats. So they say to themselves, what's the probability if we sell this many seats that the plane ends up being full? And they can work that out. I don't know if you guys are with me at all. We're almost to the point where we could calculate that ourselves, almost. But this is the kind of tool you need to be able to calculate that. Then they could actually set the number of tickets they oversell to match the percentage of the time they make people upset, which kind of controls their PR. I don't know if you guys are with me at all. if any of you are thinking about going into business, this is why statistics is so crazy useful for you, because you can control these kind of things a little bit. I mean, you got the uncertainty there, but this sort of is built in. Anyway, okay. I'm getting a little too deep into that. I am not a business person at all. So that's as far as deep I go into that rabbit hole. Okay. So let's try another problem now. What time is it? Sorry. Yes.
So that 1.6 will go in front of the Q to the 10th, Q to the 70th.
See, I wouldn't even, see, this is why I told you most of the time, in fact, all the time, I would highly recommend you do all of this formula at once. So I want you to realize something. Does everybody understand that this part of the formula is going to be crazy, crazy small? Right? If I multiply 0.11 times 0.11, that's like 0.01. So if I do it 10 times, crazy small. If I do this 70 times, crazy small. And when I multiply those, crazy small. And then I multiply by insanely big. Insanely big times insanely small becomes normal. So look, I got 12%. That's nice. That makes sense. I don't know if you guys are with me at all. So it's much better to do the whole formula at once and not have to try to keep track of the huge numbers. That's insane.
I
All right,
did,
so let's
but
try
we
to.
put that little line, when we put the line at first, I wasn't sure if we had to write it separate or just put it all in and write our answer.
Oh, I see what you mean. Yeah, that was just me explaining the concept.
Okay.
Showing you that we could do this much on our own, but we needed help with this part.
Okay.
Yeah, that's the, yeah. Okay, now let's try to set up another problem, and then I think it's almost going to be time to go. Let's do a fresh problem. Get out of here. Old and busted problem here. Let's see. Let's say the probability that somebody likes pineapple on their pizza, let's call that P. Is that going to be confusing? It doesn't matter because we're going to replace it. So one thing I forgot to say real quick about little p and little q. Little p is officially called the probability of success.
Can't see.
Oh, I'm sorry.
See the board.
I understand. Hold on. I love you guys. All right. Little p is called the probability of success. Little q then is called the probability of failure. That's amazing. A success doesn't have to be a nice thing. A success could be a dead person. It could be a rabbit, squirrel. It's just whatever we're looking for. So in the earlier problems, a success was a left-handed person because it's just what we were looking for. Okay. So let's say the probability somebody likes pineapple on their pizza is, what makes sense? I have no idea. Let's say 42%. So we'll call that little p. So the probability they don't like pineapple is going to be what?
.58.
0.58. Because what's always true about p plus q?
Has to equal 100.
Yes, has to equal 100% or 1 as a decimal. I like it. Now let's say that I pick 27 people. What's the probability that exactly, what makes sense, Jeff? I don't know, Jeff. Let's say exactly 11 like pineapple on their pizza. Those weird people. I should have polled you guys. So if you like pineapple in your pizza and you have an iPhone, I don't understand you. But that's just me. Nothing wrong with it. Somebody's got to buy an iPhone. Keep them people happy. All right. Let's accumulate what we know here. What is n? What is n? Always means the same thing. It means the total number I'm working with. What's n?
27.
27. I'm working with 27 total people. X is going to be the number of successes that I want. So how many successes do I want?
0.42.
That's the probability of success. X is the number of successes.
11.
11. And then, of course, we know P is 0.42 and Q is 0.58. So these are the four things you need to identify for any given problem, any given binomial problem. I haven't even used that word yet, have I? It's crazy. These are called binomial probabilities. Why does that make sense? Does anyone remember what the word binomial means from algebra? Versus like a monomial and a trinomial. Do you guys remember those?
There's two of something.
Good, two of something, which is exactly what this is, right? We have a success and a failure. That's why they're called binomial probabilities. There's only two outcomes. So if I roll a die, could that be a binomial probability?
No. Unless
Of
there's
course,
two sides.
no, it can. It totally can. I could roll a normal die. One situation could be getting a 5, and the other situation is not getting a 5. I'm sorry, that was a trick question, but that's all right. So anything could be binomial if I can set it up to be this and then not that. Right?
So there really is a 50% chance of everything.
Uh-oh, no, definitely not. Don't become my little brother. Please don't do that. No offense to you, Jim, if you're as if he'd watch this. All right, now. Let's set this thing up. How many total people do I have?
27.
27. And I want to choose how many of them?
11.
11. So how many of these am I going to have? How many successes? How many successes do I want?
11.
11. So it's a little repetitive, right? You got 27 people. I want to choose 11 of them to do something. So those 11 people do this. So how many people do the other thing?
16.
16, because there's 27 people. 11 people do this. 16 people do the other thing. All right, go ahead and try to plug that in your calculator. We'll compare notes. I'll write the general formula and then we'll call it a day. Woohoo. Anybody get that?
Point.
0.1534.
Yes. So about 15.34%. So here is the general formula for binomial probability. It's going to be n, and I want you to see 27 is the total number of people. So it's going to be however total many I've got, choose however many successes I want, times, I don't need prints, times P to the number of successes. Now here's where the formula gets harder than the actual work. What do I put up here for the Q? How did you get 16? What did you do exactly?
You
Subtract
subtracted from
27.
You did n minus x. There you go. So that's the probability of X successes. Well, this is the formula for it. So if you can identify N, X, P, Q, you got it. You got it. Okay, I think that's probably enough for today. Next time we'll start with the worksheet that goes over this stuff. And of course, by that time, I'll have the quizzes graded. And I think this weekend, I'm going to try to include in Canvas your current overall grade after I get these quizzes graded. Okay. So let me know if you have any questions. Otherwise, you are free to go.
Did you get an email from, I don't know if someone emailed for the 6 o'clock.
For the 6 o'clock. Oh,
Yes, I
let's see if
emailed.
it- oh, here we go,
Okay.
Nikki. All right,
Cool.
so I'm
Thank
going to
you.
set that up right now, and then I'll email the whole class with it. It should work. So who's kind of like still here? Who is the one that kind of got this rolling?
Mara.
Mara
Oh,
Benson.
sorry. All right. Who's going there tonight?
I am Nikisha.
No,
All right. Well, I'm going to create a link. I'm going to send it out tonight at 6. If you have any trouble getting in there, shoot an email. I'll be in class, but I'll check. It should work fine because I can set it up so that you don't need me there to join the meeting. So it should work without me, is the hope. All right. Okay. All right, guys. I'll see y'all next week. Jeez.
Thank you.
Thank you.
Anytime. Bye.